Hi everyone, my name is Leah and I'm the project manager for Team Hokulele's VIP section. Today we'll be presenting our 2020 to 2021 project. Team Hokulele is the University of Hawaii's first high-powered rocketry-based vertically integrated project and senior design team. We plan to launch our first two-stage rocket in the 30,000-foot category at the 2021 FAR 1030 competition, which is tentatively planned to take place next summer on June 5th. Since last year, we have redesigned the rocket's fins and recovery system and hope to complete fabrication of the rocket by the end of the school year. The rocket will carry an inert camera array payload and a radio control rover payload that will be deployed upon landing.
Hi, I'm Felicia, and here's our 2020-2021 two-stage rocket design. The first picture shows stage 1, and the second picture shows stage 2, which houses the rover payload and camera system. For propulsion, we decided to use the N3300R motor for both stage 1 and stage 2 to allow our rocket to reach an apogee of 30,000 feet. The motors are N-type reloadable motor systems with an average thrust of 3,300 newtons. Using the open rocket simulation with the weather parameters at the far site, we tested our rocket to reach an apogee of 28,500 feet in 47 seconds.
Hello, my name is Kawaiki. The figure shown demonstrates airflow effect on the rocket's fin. The orange and red streamline contours the fin and shows little to no drag effect once the rocket has reached speeds of Mach 1.7. SimScale software was used to conduct this simulation test, but due to errors, more tests will be done on COMSOL software.
This year, we decided to incorporate a slider reefing system to reduce the opening shock a parachute generates upon deployment. The suspension lines will go through the metal rings of the parachute reefing panel. The slider will cause a slight delay in parachute inflation as it moves down the suspension lines, and it will rest at the base of the parachute, ultimately causing an increase in drag and a lower descent rate.
Hi, my name is Efren, and I'll be talking about some of the materials on the rocket this year. The body tubes and the motor tubes are made of filament wound fiberglass composite, while the nose is made of a wound fiberglass transition with a 1018 steel tip. A threaded rod and a wooden bulkhead are used for internal support and house an adjustable ballast.
Each fin is a clip delta design and will be 3D printed using ABS material, then layered with carbon fiber. Both materials are lightweight and can withstand the forces encountered during flight.
Hi, my name is Matthew. Our rocket will be carrying two payloads, a rover and a camera array. The rover will be a two-wheeled model capable of traveling a distance away from the landing site while transmitting live camera footage and RC controls to and from the ground station. The rover will be deployed with either a treasure chest or threaded rod mechanism. The inner camera array of the rocket consists of two cameras, one to transmit live footage and the other to document the entire flight process.
Hi, my name is Kyler. Here we have a functional flow block diagram which illustrates the relationship between various components in a subsystem and the relationship between the subsystems as a whole. Now I'll be going over the concept of operations. The rocket is first prepped on a launch pad and ready for launch. Once ignited, the rocket takes flight until stage 1 motors burn out and the drag separation occurs, causing the first stage of the rocket to deploy a parachute, while at the same time, stage 2 motors ignite. Once the stage 2 motors burn out, apogee is reached and the avionics trigger the deployment of a drogue parachute. Once the rocket reaches 1,500 feet, avionics trigger the deployment of the main parachute, which ejects the payload canister as well. The rocket continues to descend with the main and drogue parachute. Once at the ground level, the payload canister will open and the rover will deploy and travel 10 feet.
In conclusion, our goals for this upcoming year is for Team Hokulele to compete at the Friends of Amateur Rocketry competition to test the two-stage rocket. This rocket will hold our two payloads, the camera and the rover. The competition will also provide students with networking opportunities with industry professionals, and we hope that Team Hokulele will serve as an introduction to the field of aerospace. On behalf of Team Hokulele, we want to thank you for listening today.